Okay, so let's take a look at the Dune Buggy Lab in Pivot. And if you have questions about how to collect data, hopefully I will answer them here by using video 1 as an example. So the first part of the lab is just practice measurement. So please follow the instructions on that one. That'll get you used to using Pivot. I'm just going to jump right in on video number 1 and show you guys how to collect data and kind of what information I'm interested in. So we can see here if I press play, we have one of the little Dune Buggy toys that is starting right here at our 0 centimeter position. So that is our origin, and it is traveling to the right in our screen. So remember, our objective, we talked about this in class, is we want to graphically and mathematically model the position, or sorry, the relationship between position and time for a toy Dune Buggy. Okay, so when you're filling in your Google Sheet, just go ahead and type in the areas that are kind of gray with blue text, and so that way I can see exactly what you're typing in. You can get rid of some of the extra underlines, that is fine. Also at the top, please go ahead and put your name up there. So that way, just in case I have to download your work onto my computer, I know who it is, because once I download it, it kind of does not link with your account anymore. So please put your name on things just like you would if we were in class, for just in case. Okay, the next thing in your lab are just some observations and describe the procedure you're going to use. So that's going to be for you to figure out. Okay, then the next part, you're going to type the number of your assigned video, whatever I assigned your lab group, and then you're going to fill this out for that. I am doing video number 1 for you guys, so nobody else is going to do video number 1, but I'm going to put video number 1 here just so you guys can kind of see what I'm doing. So what is the Dune Buggy doing? The Dune Buggy started at this one started at the 0 centimeter position, so right over here at the origin. Not all of them start at the 0 centimeter position. Some of them are going to start in a different location. You need to record what that location is. And then it traveled to the right or the left. This one traveled to the right, so I'm just going to type to the right in there. Next thing we're going to do is collect data. And so when we're collecting data, we want to record all positions to the left of the origin as negative numbers and position to the right of the origin as positive numbers. Just because if I'm at 50 centimeters to the right and 50 centimeters to the left, those are not in the same location. So I have to specify positive and negative. And then we're going to record our data in an organized, labeled way. I gave you guys the variables and the units here. So let's come on over to our video. First thing you're going to do is click on the tools on the top right, and those are going to give you tools available to you. You're going to click on the stopwatch, and that's going to tell you the frame number and also the time. We're just interested in the time up here. And then this middle guy is our meter stick. So we're going to click on that. And you can see here I've got 0 centimeters, 100 centimeters. That means this guy in the middle is 50 centimeters. And so I'm just going to line that guy right up here on the origin. So regardless of where your tumble buggy starts, you want to line up your 0 centimeters on your meter stick with your origin. If your tumble buggy starts on the left side and you're like, well, how do I do that? We can rotate our meter stick around, and then you are just going to line up 0 centimeters on your meter stick with our 0 centimeter origin. And on the left side, those are all negative numbers. So this guy right here, so pretty close to B, is going to be a negative 50. Okay, this guy, since we know he goes just to the right, I'm going to do this, and we'll just line this right up here at 0. Okay, and so our first data point here, the front of the car is at 0 centimeters. We're at 0 seconds. So I'm just going to make my first one 0, 0. Okay, first though, let's go ahead and put in our columns. So I'm going to start off with time. The units for time are seconds, and the variable we're going to use is letter T for time. Okay, our other column is going to be our position. So remember, this is not distance travel, this is position. It's where is the tumble buggy located. And the units we're going to use in this case are centimeters. And the variable we use for horizontal position is X. So just go ahead and stick an X in there. Okay, next, for this one, because we start at 0 centimeters at the origin, at 0 seconds, my first data point is going to be 0, 0. That is not always the case. If my tumble buggy started out here, my position at 0 seconds would be -50. Okay, so now we're just going to press play and then pause anywhere you want to, and you can like run the slider. So I recommend just kind of moving the slider around. You don't have to do this at even intervals. Okay, you can if you really want to. So maybe I want to measure the position right here at 20 centimeters. So here the front of the car is at 20 and my time is 0.5333. Okay, and then like I said, we're at 20 centimeters there. And let's move this guy over a little more. So right there, I'm at about 40 centimeters and my time is 1.1333. We can see with our time. And like I said, that was about 40 centimeters. Oops, you don't want to move your meter stick. That was my mistake. We will move the slider down here. Maybe I want to get one right at 50. So this is 1.4 seconds and 50 centimeters. Notice we don't have to do even increments. Like I've got 0, 20, 40, 50. A lot of times we do even increments, but it is not 100% necessary. Okay, and so then this next one, 1.667, I'm sorry, 1.9667 seconds, and that's at 50, 60, 70 centimeters. Okay, and then you can just keep going on and on. We need at least 5 points, preferably closer to 10 points. I'm just going to do 5 for this demo, so you're not sitting here waiting forever. Okay, you're going to click on the gear here if you want to download the table or you need some help. Okay, we don't need that right now. I'm just going to go ahead and show it to you. You can click on the menu here if you want to change up any of your column settings or add or remove a column. And then here's if we want to add more rows or delete a row. So just so you guys are familiar with that. Next, let's take a look at our graph. So we want to configure our vertical and horizontal axis. So I told you guys in the directions, we want the horizontal axis to be time. And we don't have any uncertainty, so don't worry about that. And then our vertical axis is position. And then there's no uncertainty column, so we're good to go there. Okay, and now notice your graph title already showed up, position versus time. I got position on the y-axis, time on the x-axis. And next, I'm going to do a curve fit. And hopefully you looked at this and you said, that looks like a pretty straight line, which is linear. So we're going to use this linear fit right here. And then done. And we take a look, that looks really good. So all of those dots look really close to the line. We're going to talk in the future about how to tell if it's a linear fit or a quadratic fit or whatever, but that is looking really good. And then it gave us all the information for our equation down here. So your next step is going to be to put this information into your lab report. Now, one thing I did want to mention once again, if you have positions to the left of the origin, you have to enter those in your data table as negative numbers. So you would just put a little negative sign in front like that. And I'm going to because these are all positive numbers. Okay, so I want you guys to take a screenshot of the data table right here. So on whatever device you are working on, hopefully you know how to take a screenshot. And I'm going to screenshot that guy. And then just copy and paste that. And you can delete this, take a screenshot part out, that's fine. Okay, we're going to do the same thing for the graph once you're sure that your graph is good to go. So I am going to click the hotkeys for taking a screenshot. I'm going to copy and paste that in here. If you want to format this nicely so you put this part on the next page, you can. As long as, you know, I can read it, it's fine. And then the next one, I want you to screenshot where it says position curve. And here's where we're going to do a little bit more analysis. Okay, so now you're going to work on developing your mathematical model. So we need the name of the vertical axis. So that vertical axis is the position. And the units we use for that are x, oops, which I know sounds weird having x on the y-axis, but it's okay, just go with it. The horizontal axis up here. Oops, I didn't get my horizontal axis label on my screenshot. Let's do that screenshot again. See, I make mistakes too. That's okay. Just catch them and move on. So make sure you've got time down here. That's really important. Let's do that screenshot again. Okay, so now I can see time is on my x-axis. So my horizontal axis variable is time, and my units are in seconds. So I'm just going to put an S. Next, I'm going to record the y-intercept from my graph with units. So if we take a look right here at our position curve, y equals ax plus b. So their y-intercept, they're using the letter b for, and that's 0.3681. And then the units are centimeters, and they have those right out here. Don't worry about this plus or minus 0.4472 for right now when you're writing this out. That's just telling you the uncertainty. So what this really means is that the actual y-intercept is 0.3681 plus or minus this value. So that means it could be low as like negative 0.1. Or as high as, say, 0.8, okay? So it means it's somewhere between 0.1 and 0.8. I just add and subtract this number from this guy, okay? So that's actually really important to recognize that we don't know for sure we're right at 0.368. We're just really, really close to that, okay? And then our slope is the letter A here, and that is 35.4 plus or minus 0.3677. So what that means is our slope is somewhere between this 35.4 minus 0.3677 and the 35.4 plus 0.3677. So that's just giving us the range. We're pretty sure it's within this range. I just want you guys to write down the 35.4. Just know that that's not the exact value for the slope. We're just saying it's pretty close to that. And then here's what your units. So those are over here in centimeters per second. Okay, and those units are super important. Remember, in physics, we do not want naked numbers. All of our numbers need their clothes on. So now lastly, we're going to substitute all the information into our general equation of the line. So this guy says y equals mx plus b, or in this case, it was ax plus b. So I know this is going to mess with you guys, but you got y is equal to x, or you could use the word position. For right now, I'm just going to use the word position. We'll put in the x later. Equals our slope, which is this number right here. I'm just going to do a copy and paste because why not? So there's our slope times our x-axis value, which is time. And then we're going to add to that our slope over here, which is this 0.3 number, which is actually really, really, really close to 0. So we're going to talk in the future about how we can actually round this guy down to 0 because it's so, so close to 0. So because of that, I could actually rewrite this guy as just this. And I'm just going to say here, y-intercept rounded to 0. Okay. And again, we'll talk in the future about when is it appropriate to round the y-intercept to 0 and when is it not. So this is really our final equation. So this is the equation that describes the motion of the tumble buggy in video 1. Okay. And then from that point, you're just going to answer the following questions. You'll talk about the general mathematical relationship. I told that to you, so hopefully you can do that one. And then the general relationship. So as time increases, position increases in constant increments, or position decreases in constant increments, or position increases in changing increments. So that's kind of what I'm looking for number 2. And then the next ones are, what is the real life meaning of slope and of y-intercept? So think about the tumble buggy and think about what direction it was going in. Think about how fast it was going. Think about where it started. So those are some hints for you guys to help you figure out the last few questions. So I hope this helped you a little bit understanding how to do the Dune Buggy Lab in Pivot and what I'm looking for your lab write-up. And as always, when you have questions, please ask.